Hey everyone, it's Dr. Barden here. Going over this video all about additive synthesis in Max. Here, I mentioned there's going to be slides, but I'm not going to make slides for this. I don't really think we need them, but if you really want some, I don't know, bring me some coffee or something in my office and I can put some together. But we're going to be talking again about additive synthesis today, and this is just one way of generating unique sounds that you can use for whatever you want in making music or just again whatever. So one thing I'll do is I'll go over a lot of the basic concepts, and we'll do some real simple additive synthesis here, but I'll also mention, and if we have time in class we'll go through it, that there is here we are, a tutorial on it built right into Max, which is very, very helpful. So basically what we can do is take what we've talked about already with the envelopes and combine that with the additive synthesis stuff in order to make really, really interesting sounds. And the more you kind of deep dive and get in there and really tweak the various settings, the more interesting things you can make. So again, there's going to be a patch involved in along with all of this, and I've gone ahead and put it it's in the most recent tab right here for our class meeting. I've just taken that patch and posted it here. So if you want to download it on a computer, run it in Max, there you go. That's just right there. So that's the first part. I just wanted to mention, that's all of the tutorials. But then this just kind of goes through and explains kind of what's going on in the patch here. So there's patches inside of patches, and it's kind of talking about that. If you want to find out more information about what an abstraction is, you can find that right there. But basically, you can see all of what's inside. It kind of breaks down what's happening. It links you to other important stuff. It's a good resource here to have, which is why I'm bringing it up. But what it's got right here that's handy, the idea of this patch is that it lets you both hear some preset tones, and it breaks down the 8 that it comes with in the patch after explaining what the patch is doing, and then lets you experiment with them and kind of create your own unique tones. So this is definitely very handy. You could utilize some of this in your project if you want to use it as a starting point, but don't just take it and put it in there. I'm going to be diving through your patches on your next Max patch assignment. So again, you can use this as a good starting point and a reference, but don't just copy and paste. That won't be a good time for anyone involved. So all right, so we've got all of that there, and you can get to this if you're just search Max stuff right there. You can find this online very, very simply. But some other things you can do is if you hop over to under Max, it is I think it's under help and reference. It will pop up it's the same web page here, but in a Max window, and you can just search and find the tutorials, and they're all right here, and each of them, let me just go back to this page, has an open tutorial button, and if you click on it, it opens the Max patch. So this is the one that is in the Canvas page, but here's how you can find it on any computer with Max 8.6 installed. So you can check that out there. I'm not going to dive through this right now, at least I'm not planning to. I'll keep it minimized for now. So let's actually do a little bit of Max stuff. So here we are in the patcher window, and I am going to make, I always do that, new, then a cycle object. Boom, there we go. So before we really start connecting stuff, let's just kind of break down what additive synthesis is. So the second word in that, synthesis, we are generating sounds of some kind to use. That's the first part of it there. The additive part may be a little new to some people, especially if you haven't done this before. So one way that you can think about this is it's kind of like if you're a painter. If anyone does any visual arts, you kind of have your palette of paints, and you can kind of mix them and add them together to get just the right shade of the color that you're looking for. And that's what we have happening here, but with sound. In pretty much any case, you can break down a sound into just a whole bunch of sine waves all combined together. And that's a little bit of an oversimplification, but not terribly drastic of one. So what we can do is we can then take a whole bunch of sine waves and add them together in order to create unique sounds. So I've got the cycle object here. This is what makes a sine wave. Let me make that a little bit bigger for the sake of the video, and we'll attach that there. I'm gonna just hold down the Alt or Option on a Mac key, and I'm gonna make 4 copies. Why not? Or a total of 4. Right here, I'm going to then, how about we'll make a plus tilde object. My computer, I have a lot of Max objects installed, so whenever I type in the math operators, it hangs up for just a second. We'll stick this there just to make it a little bit easier. So we're going to add all of them together with this object. Side note, this object isn't always necessary for a lot of stuff, but I like to use it to visualize what's going on. We'll stick that out to a gain here, just so we can control the volume at the end, and then we'll make an easy deck, just because I like to visualize what's happening with that toggle button. I'll go ahead and turn that off for now, and then I'll just make a message, start window, so that way I don't start triggering stuff in the other option. And then, you know what, we'll make this, we'll just have a big on-off button here, and hop over to the inspector, and we'll make it like this bright red. Why not? You know, start, stop. And I'll make the background color there, just so we can kind of see, hey, that's an important button. Just kind of adjust the colors a little bit. It's going to function the same, but if I click the button, it turns the sound on and off. And I realize this should actually be a toggle. Instead, and this is what I get for not planning this out in advance. So you know what? I'll instead of doing that for the sake of time, because I didn't plan that out, I'll just do it this way, and they'll be the boring buttons, because they need to send the message start, window, and stop. To do that, stop, start, there we go. And that's just going to involve more and several unrelated things I don't want to mention. So that's my fault for not like deep dive planning this video out beforehand. So anyways, let's start with the cycle objects here. So we're going to combine these 4 sine waves into a composite tone that we can use here. So what we can do is start off with the frequency. So I'm going to make a new float number object, and I'm going to start by connecting it to each of these independently. And we'll start off, rather than hearing this be 4 times as loud as it needs to be, let's put this at 500. Start the sound. That's cool. That's great. So we hear that there, but we can combine this in a few different ways here. So the first thing we could do is put a separate floating point number for each of these cycle objects. And I'll do that real quick, but it isn't always the most practical thing to do. So if instead I just do it like this, this is great for illustrating what we have, and I'll add these up. Doesn't really matter what inlets that goes into. But let's see, let's put that back at 500. Let's say 1,000, 250, and let's go with 125. Here we are. So we'll lock that, start the patch, start just the window. So here we happen to have multiple sine waves all coming in and giving us this tone that we're hearing here. Don't want to start getting some digital clipping, but you'll notice they blend together pretty well, and I specifically picked things that were all multiples of each other in some way, starting around 500, and then we got the high, an octave lower, and an octave below that. It kind of gives us this organ sound, which I kind of like. And again, if we wanted to isolate all of that, we could just... we already listened to this one. Yeah. It doesn't like that one for some reason at the volume. I'm not sure exactly what's happening with that. It's kind of weird, but there we are. So at its core, that's it. Like we're combining different sine waves at different frequencies and different volumes. We haven't got to that part yet, but combining these different sine waves to make a tone. So when the frequencies are all multiples of each other, then we get this very nice concordant harmonious tone. They're all in this case they're all octaves. So if this was octave 1, 2, 3, and 4, again, every time you double the frequency, you go up one octave. We get this nice kind of overtone happening here, but it doesn't have to be. Let's say, you know what, I'm going to make this a little easier. 100, 200, 400, 800. Just so that way the math is a little bit easier. But let's say we wanted to change that. So maybe we'll keep this one at 250. Here we get that little difference in there. This is now slightly higher. Kind of get that fifth happening. This could be, maybe this was 700. It doesn't quite mesh as well. So maybe I'll put this, if I don't like this one, I'll put that at 500. And again, I'm just kind of fine-tuning stuff. 500's kind of neat. I kind of want this 800 back in there, though. Anyway, we'll play with that for this. Nothing too crazy here, but this will be part of our tone. But right now, again, it doesn't like it at higher volumes. but right now they're all at the same volume. So what we can further do to blend these together is adjust the volumes. And again, we could stick a gain object in there for the sake of this lesson to illustrate what's happening. That's what I'm going to do. But at the end, I'll show you a slightly more practical way to set all of this up. 5. So first thing I'm going to do is take all of this, scooch it down just a little bit. So if you select an object and hold down the Shift key, when you hover it over a patch cord, you'll see it light up. When you let go, it inserts it into the middle of that patch cord. So that's a really handy way to quickly connect stuff. And then there you go. So I'll line this up just a little bit more. So now we can control the volume of all of these tones. So if we start that, we're not hearing anything, but let's bring in the fundamental. I want a lot of that one. That's too much of the 600. I want just a hint of it. There we are. So I've crafted a balance of all of these together. So again, we could change the frequency, we can change the volume of each of those frequencies, and send that, blend them all together and get this unique tone. This is a lot more interesting than just this. Ooh, I should connect that. Come on, give me that back. This. That's boring. This is more interesting than that. And again, this is a kind of a simple example. The more you add, the more complex your tone can be. Whether or not that's a good thing for what you're wanting to do depends on what you're wanting to do, really. This is, again, I'm showing you a tool at the moment. So you can play around with some of that. This also can come in handy when we're combining this with the envelope stuff that we're doing before. So if I go in and multiply tilde, again, that's gonna take a second. There, line, tilde, and we'll just shift. Oh, is it not gonna do it? Oh, it doesn't like that. All right, well, we tried. To that. So if you're following the signal flow, we're adding all of these together into one signal and multiplying them all by the line, the message that we're going to send it. So again, we're going to start at 0, and then we're going to go to 1 over, let's just say 3/4 of a second, 0.8 over... how long do we want to hold this out? Let's say half a second, 0 over 1/4 of a second. I forgot to connect that. Bloop. So now, and my cat feeder is going off in the background. If you hear that, that's what's going on. If we start this up, we're not hearing it, but then... And I think I want this shorter, so let's make that 400. I'll make you 200, and we'll make you 50. I just want a short note. So now we can trigger this note, to have whatever shape, set up of frequencies that we want, and can adjust the mix of those frequencies. So this is all very, very handy, but it's not practical to use in like a performance sense. Like if you're gonna make something like this, is great for fine tuning and getting everything that you want tone wise. But if you wanted to, do something with this in any practical sense, there's other and better ways. So what I'm gonna do real quick is show you just a few of those right here. Nothing crazy. I'm gonna duplicate this over here. We're just gonna kind of do it over there. So we'll stop the audio. And then I'm also gonna need these cycle objects and the line object here. So one thing that is going to be very helpful, especially when you're starting off, is again having your your frequencies, your partials, if you're familiar with that term, be in some way related to each other. So we can boil this down to one number, essentially. So let's say this is the tone that you want, and that part's not going to change, and you just want to be able to change the frequency. If the tone is going to change, you're going to want to be able to adjust these independently. But we're saying that in a like you're in a performance setting, you have the sound you want to use, you just want to be able to play different notes with it. We'll make one single float here, and we're going to connect it to all of them, all 5. Now, normally, this would just output the same signal 5 times. It'd be 5 times as loud. That's kind of boring and annoying and problematic sometimes. But we can figure out the math that we want to use. So I'm going to use this 100 hertz here as the fundamental frequency. This is the main frequency that we have, and I'm building literally the same thing on both sides, just so you know. And if we just make here, and we'll just do a quick little bit of math, multiply by 4. You can kind of see where I'm going. 2, 3, 4, and I'll even keep them in the same order here. So multiply by 4, multiply by 5, multiply by 2.5, and multiply by 6. So this will take whatever value comes in. It can you'll want it to come in the first one, because it'll that number will trigger the multiplication. If you send it into the into this blue inlet, it will change what number you're multiplying by. Just FYI. But if we just send that in here, didn't had both those selected. And again, I'm doing this in exactly the same order. We'll just set that up, make it kind of pretty. Now, whatever number we send in, it will automatically create the same relationship between the different partials, just automatically. And I'll do a slider, because I like doing the sliders here to control the pitch. Let me just info. We'll say it's got a range of 1,000. There we are. We'll make that a little smaller for the sake of what's on screen. So I've got that there, and again, we could just send all of these into the gain object, but I kind of like when I'm teaching, at least, I like the visualization of the addition object. So I have that there. I'm going to just disconnect this for the moment. But now if we were to connect this and then just add up all of these together, we're combining. Start the sound. Oh, it's because they're still set to 0. 0 times 4 is still 0. So let's put one. That's close enough to 100. You can hear it's very close, but the tone is effectively the same. The pitch is a little, slightly off, so that's where we're getting that. But now, so that's gonna sound a little weird with the slider. We're just going to do that. So what I'll do is I'll pull in my K slider up here. Keyboard slider. And which outlet is it? Key value, velocity. Okay, so I think I need a new object we haven't talked about. M2F converts a MIDI note number to a frequency. So this virtual keyboard here outputs the MIDI value here, but we send it through the M to F, MIDI to frequency, MTOF if you're feeling fancy. Something kind of like that. So it has its perks, but you'll notice right now it's not quite what we're wanting. It's still only outputting that constant signal. So if we combine it with our envelope, we should be able to see if this works. Yeah. Here we are. So I'm just messing around at that point. So what I have done, and maybe this will make it a little bit more clear as to what's happening. I'm just gonna put this bang here. Is this. So there's a few parts happening in this patch that aren't happening over here on the left. So on the right, and if I just combine this, or I should say on the left, this is set up in a way that is extremely customizable. Like you can set the frequencies, you can set the level of each of those frequencies. You can, if you change this, you could change up the, how the shape of the note and all of that. That's great. But over here, it's a lot more practical for use. And I realized I forgot the gain part here. So if I just copy, paste, or you know what, I'm gonna just do that this way. 2, 3, 4, 5. This is so the gain object is effectively just multiplying the signal. So I'm just going to manually. That looks like about 0. Not 7, 0.75. Why doesn't it? Come on. There we are. This one looks like 0.6, 0.65. I'm just kind of ballparking these. 0.8 and another 0.6. So I'm just gonna slap these on here. And again, we can change this again by sending a number into that second inlet. But since we're trying to make something that is, fairly constant, we don't necessarily need to. I'm also going to just move a few things around just to avoid the cables kind of overlapping, and it might make it just a little bit easier to read. Okay, so there's a little less spaghetti happening here on the screen. Not a ton, but a little less. There we are. We can kind of see everything a little easier. So again, this one great for setting up, designing your sound. This one's becoming more practical for using. So let's say we made this as our template. We knew that these were the approximate volumes that we wanted and the frequency partials that we wanted to have here. But now we want to actually use it. So I just recreated this, but I took out these graphic user interface, these GUI objects, and just kind of hard coded it in. So again, we could change this up, but for right now, it's going to be the same all the time. The only thing we can directly change is the pitch that's being played and the volume of the outgoing sound. The way I made it so that way it was playing more of a note was with this K slider here, we're outputting a message that is the MIDI note. So right now, we've last played MIDI note 69. Nice. And we just converted that to a frequency to control the cycle objects because they see frequencies. But also, whenever that gets sent out as a message, if you send any message, anything into that first inlet of another message object, it just triggers the message to send. So I just put a button, a bang object here, so that way you could see that when I click a note, it lights up, and that's causing this to trigger here. So we're changing the pitch and then also triggering the note. Let me make this just a little bit longer of a... Ooh, no. 50. I wanted to make you 800 milliseconds instead. We could set that up there. We could, again, keep crafting that. Maybe, heck, even I want it to get a little louder over another 700 milliseconds, and then fade down to 0.25 of the volume over 100. I don't know. It could be something weird. I don't know. That wasn't a very drastic... I didn't like that as much, but if you look in the tutorial patch, it shows a few ways to like have more complex sound envelopes. So definitely explore that. So in this way, once we've got the basic functionality that we're looking for, we can then start turning it into something that people can use. And that's going to be the bulk of the additive synthesis stuff for right now. Again, we're just combining multiple sine waves together, and then adjusting just the pitch of those sine waves and the volume of them and combining it into a single audio stream. And then once you combine that with an envelope, you've got a note, you've got a tone. And again, you could connect this up to a MIDI controller or other devices and play along with stuff. It can be a lot of fun. So if you wanted to use the K slider in your Max object assignment, that's totally fine. Nothing wrong with that. I think the example I put in another video is just a real simple, just buttons to trigger it. So I think that's where I'm going to end it today. Excuse me. The next thing I'm going to be doing is how we can further make this into a tool that can be easily used. So I would recommend saving this, taking a screenshot, having some way to easily pull yours from class back up. I'll put this after class into the Canvas page so that we have it. And then in our next meeting, we'll start from here and turn this into, again, I mentioned the abstractions and sub patches earlier. We'll turn this into something that we can actually use in a patch as a tool. And that's, like I mentioned at the very beginning in our first meeting, the goal outside of learning a lot of the basic tools and tricks used in computer music and generating all of that is developing a toolkit that you can use to easily create your own things. So that's going to be the very next thing we talk about in our next class. But as always, if you have questions, don't hesitate to send me a message. I'd love to help that out however I can. Stop by my office hours. All the main things. So that's what I'm going to end it today, and I'll see you next time I see you. Bye.